Thank you, Patricia. Just an announcement before we start. In parallel with this session, there will be the start of the prototyping, the innovative prototyping lab, the LOT methodology with Arcopol. So this is in a parallel. Okay, and we have Daniel Garriga from UPM speaker in the prototyping lab session. So to access the parallel session, you can go on view schedule and select the LOT methodology. This session will happen in parallel with the current one. So just so everyone is aware of the session.
Thank you. All right, I think that we are also technically ready for the next session. Welcome again, everybody. I hope you enjoyed the coffee break. And as I already advertised a little bit in the morning, now we have 3 rather larger presentations, starting with Patricia Kassler from Tekniker. They are one of our demonstrators. They're working on a tribological information system and particularly on tribological characterization, and it will be followed by Katerina Kari from IKEA Systems, and then Evgeny Karlamov from Bosch AI, and he will also share his experience and his team's experience with adoption of some technologies in the context of course, OntoCommons. And without further ado, I would like to invite Patricia to the stage, at least virtually, and enjoy the talk.
Okay, thank you very much, Umut, for the presentation. I hope you can all hear me. Is the case? Yeah. Umut? You hear me? Okay, perfect. I am going to share with you all the outputs from our demonstrator, how we have been performing it, the lesson learned, and so on. This is okay. Just as a brief introduction, Tekniker is a research center in Spain. We are very specialized in the manufacturing sector, and we have different research areas. For this demonstrator, the most important are the intelligent system one and the surface engineering. And we also have some infrastructures. Here it's very important, the tribological laboratory. This tribological laboratory supports both the surface engineering unit when they are defining, for instance, new coatings or so on, but also it is used to provide services to the industry regarding tribological experiments to allow them characterize their lubricants or new coatings or new materials. So it's to contextualize our role in the project. Okay, the scope of the demonstrator is the application domain, is the tribology. Tribology aims to study the friction, wear, and lubrication between interfaces surface under specific conditions. And this is very important for the industry because it helps to understand the behavior of materials, also lubricants, coatings, and so on, under specific operation conditions. This is key for developing new products. That is the case for our unit, surface engineering unit, and our clients, and driving new materials into sustainable solutions. So the scope of our demonstrator was to reduce the number and the size of experiments and this remains in the cost and time, to identify this behavior by exploiting both our own data, results from tribological experiments, and also third-party available tribological data. And what are the challenges? The point is that there are lack of standard of the way to formalize this tribological data. So the approach that we have followed in this demonstrator is to use semantic technologies to perform the formal and unambiguous representation of data and allow this data access. The starting point was at the very beginning we have these laboratory books and really not even in Tekniker that we have this ICT support. The information was in the laboratory books paper-based. In the framework of the iTribomat project, we've developed the Tribo connector that allows us to introduce automatically from some machines that have this possibility or manually perform either tribologies, the information from the tribological resource into a non-SQL data repository. Then in the framework of the OntoCommons demonstrator, we have performed an ontology, the Tribo ontology, I will explain later on, and perform this automatic mapping from the data repository to the ontology and get this knowledge graph representation. And then we have been doing some proof of concepts about potential use and exploitation of these results. So to do so, we have used the LOT, linked open terms methodology that has been the driving working process. And I'm going to explain you what we have been performing in each of these steps and which tools we have been using and the results we have been achieving. Okay, for the very starting, as we have put in place a multidisciplinary working group involving tribologists and ontology experts. These materials and ontology knowledge. We have got these inputs from the iTribomat project that they have defined, as I told before, they are not standards or formal representation. So they have set and identified which should be the minimum requirements to define a tribological experiment. So with all this input, we have defined a set of competency questions that are the starting points of our demonstrator. The next step was to conceptualize the ontology, what we wanted to represent. For that, we have been using UML diagrams. We have been using visual paradigm. There are many others. We have using this one because it's the one we use when we develop our ICT solution, and it's the one we were used to. So in this, we have represent the main classes that should be there and the main relationship between all of them as a starting point before the coding of the ontology itself. Then we have been looking for potential reuse candidates. For that, we have been looking in WB3ID.org, in Linked Open Love, Industrial Portal, Math Portal, and performed some web searches. At the end, we found a potential candidate that was the Tribane ontology that was in the tribological subdomain, but after an analysis, we saw that we wanted to use it as baseline and extend it. But after an in-depth analysis, we decided to go for developing a new ontology and aligning it, because it was not with enough quality and not cover all the things we wanted and not in the extension we wanted. This search for the candidate was not so easy because things are quite fragmented. At the end, it was a result of our website. Then we started to develop the ontology, and we use as an ontology editor Protege, that you all know perfectly. And then, so the ontology we have generated is the Tribont ontology. We have published it, so you have this link that if you want, you can access. This is a modular ontology because we wanted to improve reusability. It's composed of the main ontology plus 4 other modules and uses an ontology design pattern. There you can see some statistics, or the number of classes, object properties, data properties, and individuals. But we have also included some equivalent classes and 11 rules to improve these reasoning capabilities. In the different modules, we focus on the main aspects that are involved in these typological experiments, that are the experiments themselves, the samples that are used in the experiments that are made of different materials, and the equipments that are involved in the experiments. We have also, let's say, a core module that includes all the main classes and object properties and data properties that are common to at least 2 different modules. As I said before, we have not reused as in full an ontology, but we have decided to go for the alignment with relevant existing ontology to improve this interoperability. And what we have done since now, we have take this design ontology pattern, and we have aligned it with both Dolce Light and QUDT. And the different Tribont ontology modules have already been aligned with Tribane and Tribodatafair ontologies that are in the tribology domain. The Tribane ontology was identified as potential reuse candidate at the very beginning, but in the meantime, during the development of the demonstrator, a new ontology was identified that appeared in this time. That was the Tribodatafair, and we also analyzed it, and we have already performed the alignment of Tribont with these 2 ontologies to contribute to an harmonized ontology ecosystem in the tribology domain. In the meantime, we are also, but this is still a work in progress, we are aligning it with all the relevant ontologies in this material domain that as Camilo and also what we are working in the extension of this sample module that I mentioned before in the Tribont ontology. We extend it with the IOF core ontology to represent the sample preparation process. We think that it can be used, so this is something we are working on and still in progress. The alignment modules that are already available, the ones with Dolce Light, QUDT, and the characterized, and the ones with Tribane and Tribodatafair, you can find them in these links in the WB3IDO. And you can see also in the picture some alignments we have performed. To say that the alignment process is quite time-consuming and is not that evident, at least for us, because you have to go to the ontology, you need to really understand the ontology you want to align with. In some cases, for instance, in the Trivena and Tribodata Fair, there were very few or no metadata, and the process has been not so easy. In other cases, there are more metadata, but it's not that easy to understand the full concept of the ontology. The next step, once we have already developed, let's say, the different modules of the ontology, the next step was to instantiate it. We made a manual instantiation with 4 complete experiments, covering all the aspects important in the tribological experiments, and we started doing some tests. For the consistency and inference evaluation, we use both Pellet and Hermit reasoners in the context of protege. Then we use the OOPS ontology pitfalls, and no critical pitfalls were detected. And then we also, as I mentioned, it's a modular ontology. We wanted also to identify how modular the ontology was. So there is that we use TOM, that is the tool for ontology module metrics, and the results you can see there. There are more. The tool provides you with more metrics, but we have just highlighted the mandatory ones. As you can see, the results are quite good. To perform the test, you have to take every module and try against the others. And all the metrics are good in the intervals, and the only one, the complete, that should be true is false, but it's because we have used this characterized in the core ontology, and we have include some disjoint in the classes, but if you eliminate them, it becomes true. So it's not an important issue, and the results we think are quite good to demonstrate the modularity of the ontology. So the next step was to say, okay, things seems to be fine. But now we have to see if we have a good candidate for publication. No? So what we did was to deploy the ontology with instances in an RDF repository. We did in two. One file we use Overlink Virtuoso 8 plus spin because I said before that we have rules, so we needed this spin to execute the rules. And in a second phase, we use DB graph because they had a plugin to MongoDB that was the non-SQL repository we have in place. So with all this, we go through all the competency questions that have been identified in the beginning and perform all the Spark wells to validate that everything is well covered. Then, once we have decided that and we make some fixing and so on, and when we decided that okay, this is the one we are publishing, we complete all the metadata following the WIDOCO recommendations, and we provide metadata at the level of the ontology on different modules, and we also include metadata in all the classes, object, and data properties. And we generate all the complete HTML documentation to be uploaded and published by using WIDOCO. And we have published, as I mentioned before, you can already access the link. It was published last week, so perhaps some fixing will be needed, but it's there. And we have already requested to be uploaded in linked open vocabularies log, and we are also in contact with ACO, and we will upload it in the industry portal in the next weeks. Okay, once we have this published in WB3ID, we were able to perform the fairness assessment by using FUCS. And once we will upload it in the industry portal, we will be able to pass the offer assessment that is already integrated in the industry portal. And these are the results from the fairness assessment process. As you see, they should be better because, as you see, they are quite good in the interoperable and reusable parts, but not so good in the findable and accessible. This is because we are still pending on the answer of LOF. And we expect that once we publish it in LOF, all these metrics will improve because they are not, now they are zero. They will improve and we will get a quite good result. And for the last step of the LOF methodology, we have this maintainability. For the maintainability, we have also made public, and you have there the link, the Tribont ontology in GitHub. So if you see it and you find potential improvement on things to fix, please tell us. You have this access, you can stay playing with it. And this was for the first part, for the data documentation and so on. And then the other part of the demonstrator was to use and exploit.
Patricia, sorry, you have 2 minutes, just to remind you.
Sorry, how many?
2 minutes.
Oh, okay. Manual, we did this manual instantiation for the ontology evaluation and validation. We made a proof of concept to automate the instantiation by using JSON LD and the MongoDB plugin that is included in dbgraph. But one of the things that we found is that, for instance, to use reasoning, the knowledge graph must be materialized in the semantic repository. So this leads to duplication because we have them already in Mongo, and we have to put them in the semantic repository to apply this reasoning. Okay, for the user interaction, we have been using parametric services with Python. It's good because we can have all these predefined typical questions and you can enter the parameters, but requires ad hoc development and do not support this navigation through the related resources. For the visual exploration, we have been using dbgraph. The users like this concept because it's intuitive and allows this navigation, but it's still too complex for end users. So, but this visual exploration is something that we should explore more in depth. Lessons learned: benefits from the introduction of the semantics, better representation. We can enrich data. We have this extended data retrieval, this taking advantage of these reasoning capabilities. The lack is the coexistence of non-semantic repositories during operation. We have to put the same information in the RDF's repository, but the real is that in many cases the information is already in other legacy systems. and there is a lack of really intuitive visualization and navigation on tools. From the use of the methods, the lot methodology and tools is helpful to standardize the process, and also regarding the industry portal, I think that it can help to identify candidate ontologies, and also you see this alignment process that is quite complex, but still there is a limited set of available ontologies, so it would be much better once it gets a lot of more. And the gaps is that lot is focused on the ontology requirement process, but we need more methods and tools to really put ontologies in production and have to exploit them. And they ask us, and for the future, we bet in the ontologies and semantics. You can see that our demonstrator paves the pathway toward what we have in mind for the future is this material data sharing across the value chain, and the semantics is in there and is quite important. And because as I told in the beginning, we want to use our own data, but also third-party data that will provide us the full potential. And sorry for being too long. Thank you. That's it. And you can contact me at any time in this email, please. So, Umut.
Thank you very much.
Sorry for the extra time.
Yeah, great. Yeah, thanks. I think we still have some time for questions. Hedy, from very behind. Yes, we can bring you something, I think. Yeah, but we need to grab it. Two. I mean, we will need this later also, so let me turn it on.
I think it works. Oh, you have one. It doesn't work.
All right. So thank you, Patricia, for the presentation. Really amazing to see how ontologies is adopted within your use case. So I also like very much your slide on the feedback with semantic technologies and ontologies, what are the benefits and the gaps. And also I'm happy to announce that regarding the gaps on the ontologies, now we integrated a tool within industry portal called Soulessence that answered the gaps regarding the use of the ontology, the exploitation. The tool includes some features for visualization, for knowledge graph generation, for mapping with databases. All of those features are already in Soulessence. So I think when you integrate your ontology in industry portal, will be interesting to also to test the tool and have your feedback regarding it.
Okay, great. Great call.
Thank you.
Any other questions also from the online audience we could, of course, have? Yes, we have one more question to Patricia.
How can you explain a bit how you make that?
Sorry, I don't know if it's only on my side, but there is a noise.
Fair principle. I'm kind of wondering also like the interoperability, like all of them get like a full score. Like.
Sorry, I didn't.
The question was, can you please also explain how you measure the fairness of the ontology, particularly interoperability part?
The fairness of the ontology, we've used this FOOPS tool that is provided by the UPM, and this provide you the metrics on the interoperability and also the accessibility, all these metrics. You have to select the ID, the location, and you get the report with all the potential things to fix and so on. I have included in my presentation the link to the FOOPS. And also we wanted to pass, but once it is integrated in the industry portal, this offer tool also that will give us potentially some hints or potential improvement consideration.
So yeah, industry portal has also FOOPS in it if you're interested. We have this tool in the ecosystem called industry portal, yeah, and you can also find the FOOPS. All right, maybe one last question. Okay. Anyway, time-wise, we are also now at the border. Thank you very much, Patricia. It was great to see again how far you came with the use case since the beginning of the project. And yeah, and I hope we meet again towards the end for more exchange. Yeah, and thanks again.
Thank you very much.
Round of applause for Patricia.
Thank you.
All right, so without losing any time, we continue with Katarina Kari, the lead ontologist of IKEA systems, and she will now tell us about her experiences adopting some technologies.
Hello, everyone. My name is Katarina Kari, and I represent IKEA Systems BV. I'm their lead ontologist, and today I'm going to talk about a use case where we're using knowledge graphs, and it's a knowledge graph driven recommendations. So IKEA sells furniture, and we sell them also online. And what we want to do is we want to give our customers good recommendations on what to buy when they're looking at other furniture. And this particular use case addresses selling accessories together with furniture. So we've got it really well nailed in the shop. If you ever look at a piece of furniture like a table or like a sofa here, you will also see a lot of other smaller products, accessories as we call them, that really make this sofa really like comfortable or helps you maintain its good quality or having it look good. And that we are really good at in the store, but online not so. So when you're in the IKEA store, it's kind of a manageable thing. You have 25 or so sofas displayed. It's not all of the sofas. And then for each one, you kind of have 1, 2, 3, or 2 to 3, maybe more accessories together with that sofa. So for the people managing the store, the actual physical store and the actual people, this is easy. They just kind of need to do that for 25 sofas, and it's totally manageable. But when you're online, we actually get the whole variety of almost 2,000 sofas that we're selling because all of them are online. And then for each one, you probably want to provide more accessories, like 10 accessories, because not all of them are in stock, or maybe they're not sold in that particular country, or maybe you want to do a little bit of steering and personalization. So you actually need more accessories. That means you have to do 20,000 combinations. And that's not manageable by a person. So in the store, that's fine, 75 combinations, but 20,000 online, impossible. So therefore, we need to generate these accessory recommendations for any furniture, not only a selection, but all of them. And we cannot do this manually. Um, in general, today, in every e-commerce you go to, we are using the wisdom of the crowd. This is a statistical analysis of how other customers are shopping. That's standard. That's a total industry standard. Sorry. And which is driving recommendations. You see it all the time in any store. And I mean, wisdom of the crowd is just based on other customer behavior. And but when more and more customers are opting out of cookies, the amount of data for this wisdom of crowd declines. So that's one reason why it's not necessarily a good approach. Another one is that it just gives us the what, the end result, but it doesn't actually give us the why. It doesn't say why a product is good. So we lose a little bit of information, a little bit of quality recommendation here. It can also generate mistakes. This is from Amazon store. Yeah, this is from a famous American online platform. You might recognize the typography. And one of our colleagues actually who had the flu was buying a nebulizer, to breathe in steam and kind of make the throat feel better, and got this recommendation. Must be driven by wisdom of the crowd. Don't think Amazon's doing anything manually. And that's hydrogen peroxide, which obviously is a fatal connection here. Don't inhale the fumes of HP. And why are they recommending? Like, it seems the wisdom of the crowd is moving towards this, but this could also be because what Trump was saying about how to cure COVID. So wisdom of the crowd can actually also amplify misinformation. And also, if we in IKEA would be using wisdom of the crowd, we would be missing out on the opportunity to serve quality interior design and knowledge to IKEA customers, which IKEA is really good at. We design all of our products. We manufacture all of them. We hold the whole value chain in our hands. And there's even some accessories that are exactly designed for some products. So why should we give this responsibility to the customers shopping the products when we are the experts of this knowledge? So then the starting point is, what if we would do things differently and not use the wisdom of the crowd, but we actually capture why certain accessories go well with certain furniture? And if we capture this, we could give better recommendations and maybe even have this data available for other applications. So the moment we started developing this approach, we already had people from computer vision knocking on our doors and saying, hey, you have the products that are usually found together information. We need this because now we can do better visual recognition from images of which products are there. Like, we don't have to actually assume that it could be any product, but we can say when it's a sofa, most likely you will see cushions and throws and lint rollers next to it. So this is like an unexpected reuse of our knowledge. And it's not hard for IKEA because we have interior designers who have very solid mental models under which they operate and with which they combine the accessories. And now it's all about just getting that information out of their minds. So we capture these mental models as business rules. And for that, we use the knowledge graph approach. I think that OntoCommons is a little bit too obsessed with ontologies only. So I think that's just a third of the story of what knowledge graphs and what using ontologies is about. Ontologies are capturing some like very essential business concepts, and it's capturing like the data model, the logical data model, and the ideas and the business. And if you look at an ontology, that will probably be a very good thing. You could, almost hopefully print it out. It's just in the hundreds. and you could take it over, you could take it to your home over the weekend and learn it by heart, and then you would be quite versed in like the domains, terminology, and understand a little bit what everything is about, hopefully, if you have good ontologies defined. So ontologies are good for that, but it's not the end of the story. The second part is that then you have very specialized instances. So, I'm actually just wondering, yeah. Let me just give my rant first why we shouldn't be ontology obsessed. But then you have the second layer here, this middle one, the blue one, which is about very specialized instances. So these are instances that we refer to many times. For example, for a sofa, it would be any kind of type of material. So the material in itself is a concept that's in the ontology on the green layer, but it being wood, or it being wool, or it being down-filled, or whatever the material is a specialized instance because it has a very high page rank. So if you think about notes, there are a lot of products that are made out of wood. So you have many products and they all refer to the instance of wood. Thus, wood has a high page rank, a lot of links leading to it. But it's still an instance because it goes from like a product to a type of material to wood. So we have these high page rank instances, and they are basically forming the control vocabulary of the organization. So we choose to use, say, wood. We don't say, or we are choosing to say even more. We're saying birch, and we're saying other types of woods and so on. So that is also a very important part. And hey, this is not ontology, this is taxonomies. So when I think it's a bit of a false accusation to say, like we said yesterday in the consortium meeting, that taxonomies is like a first version of an ontology. The companies start with taxonomies and then they make them into ontologies and then they are knowledge graph driven. No, at least in IKEA, we're using both, and both have a very important role. The ontology is there for the data model, whereas then the taxonomies are to capture control vocabulary and to have ownership. Like the team that knows best about the materials should be the one who owns the materials taxonomy. And then the other expert team, knowing about how our customers behave and having done all these like customer surveys and customer research, they should be the ones who control, for example, the vocabulary and the taxonomy of activities that people do in their homes and so forth. And then finally, this the black layer, the biggest one, that's the actual data in the knowledge graph form. So that's when you take your data, transform it into RDF, and have it in a triple store. And that also plays a role because you need to understand that that operates differently than an ontology. And I see people mixing these up all the time. I'm seeing ontologies being designed where actually the ontologies should, part of those classes should actually be on the instance level. And then it's also a very, let's say, a balancing act to always know what goes on to the ontology and what goes into the instance level. So this is all the time something that needs to be understood and discussed and researched. Now, when it comes to our knowledge graph driven recommendations, we use the ontology level, the green layer, to define our business rule data model. So not the actual business rule, but the business rule data model. So we say that there's a certain product attributes that kind of determine how we would define an accessory. And then there are also ways how we would define the furniture, or the business rule to find the furniture. And then the properties play a big role. So actually this, the biggest part of this ontology is not classes, but it's properties. There's a lot of different kind of properties for how accessories fit a furniture and go well with it. So for example, there is the quality of that it makes it comfortable, or the quality that it helps caring for it. But then we have many more, and we have a bit of hierarchy there also in our properties. Then on the taxonomy level, on the specialized instance level, that's where we are actually defining our business rules. So our IKEA experts are working with combining taxonomy concepts with each other to define business rules. So they're saying from the taxonomy of shape of products like cushion, and from the taxonomy of like what they are designed for what kind of use they're designed for, we get the suitable for indoor as one concept in those two different taxonomies, and that together defines the rule of cushions for indoors. So then cushions for indoors is something that makes the furniture indoor sofa comfortable. And that's a definition. I actually have non-technical domain experts authoring these kinds of rules. And our biggest challenge is providing them the tools to do that. So first, when we started this project 1.5 years ago, we thought, oh, they're going to learn OWL. We make them learn OWL, and then they're going to do all of this. That didn't work. We need to make them tool enabled. So then we put a lot of our attention to building the right kind of tool for this so that they can actually visually connect these things and then visually author the business rules. And that now works much better. They're much more productive, and we're getting a lot of really good quality rules from them. And then finally, on the data level, with a bit of reasoning and data transformation, we actually can then connect, for example, this beautiful Svarthö cushion. And sorry, the prices are in dollars. I should have checked them in Norwegian crowns. Sorry about that. But the Svarthö cushion actually makes the Söderhamn sofa more comfortable. So how do we then create the recommendations? We have these rules. We say the lint roller helps caring for the indoor sofa. The throw and the cushion for indoors make it comfortable. And then we get all the lint rollers, all the cushions, and all the throws on the left side, and we multiply it with the thousands of sofas on the right side. So we take a Cartesian product of these, and that helps us to really create hundreds of accessory recommendations for each furniture. And we do this, repeat this with different business rules for all the furniture. And that's how we can actually create what we call a stream of recommendations. This is not based on wisdom of crowd. No, like weird things can happen, but this is actual quality interior design and knowledge with which we can now serve our customers online. So to summarize, the ontology defines the expressiveness of our business rule model. If we need to at some point say that we have another type of, like an accessory could maybe even make something more secure, then we would introduce that on the ontology level. Then the categories level, the taxonomy level, is where the actual business rules are in action. And then finally the recommendations and the new connections for each product on how they suit each other is on the data graph level, on the lowest level. Yeah, this would be a good time to take questions. Yeah, sure. So, wait, does anyone online have a question? Not seeing, but yeah, but maybe someone from the room. Okay, please, maybe, do you mind coming down here and talking to the mic? Or then, otherwise I can also repeat your question for people online. If you want to do a bit of sports, we're all sleepy anyway. And then we get lunch afterwards. Please come over here so you can really see the mic.
Okay, I have two suggestions really. The first one is that when you are building your models, that you should take into account the function of complementary colors, because that is quite important. And the second one is when it comes to environmentally aware customers, that they probably want to evaluate products and sequences of products according to environmental friendliness. And I presume that you are using a large language model. Oh, that's, I think that you should look into that, because then you don't need to make Cartesian products of everything more or less. You can be more accurate with significantly less amount of combinational work, combinatorial work. Thank you.
Thanks for so the combinations are done based on the business rules. We're actually not manually doing the combinations, so we don't have combinatorial work. If we would use a large language model, we would again lose the control of actually giving the quality recommendations. But we are thinking of the approach of large language models suggesting business rules and then IKEA experts evaluating them to save time. But large language models always need to be trained as well, so it's kind of, it's a bit of a catch, and like I wonder how well it then actually saves the time. Then when it comes to colors, we are already doing that. We're also coordinating according to style and budgets. So those are the things. And when it comes to sustainability, that's going to be a project in our roadmap and like an application to add to this. Any other questions? Umut, please come over. Umut has a technical and non-technical question.
All right. So the non-technical one is basically, you said like first you thought people will just learn OWL and then do the stuff, and it didn't work out. And my question is like, is there something that you're trying right now, and I think this is already in some production system somewhere, that doesn't work? So that didn't create the impact that you were expecting, that was related to using semantic technologies.
Wait, are you saying that if we have a business rule that didn't work?
No, not necessarily, but I mean, you explained your approach, and is there any part of the approach or on the way that you towards your approach, was there something related to adoption of semantic technologies that you tried to implement, but it didn't work for some reason?
So one thing is, for example, us doing the combinations. So we are generating them based on these business rules, and we created our own reasoner to do this. Now, the problem with creating our own reasoner, it's like a script that runs, and it will take, currently it's a 1.5 hour delay. So our knowledge experts actually don't have the possibility to evaluate in real time the kinds of impact their business rule has on these connections. So now we're looking into triple stores that have really good reasoning capabilities, and can bring us to real-time reasoning.
So my second question is the technical one. What is this? So from a formal perspective, because you had this pyramid, right? You had concepts on top, which you call ontological layer, and then you have the taxonomy and data. So data I understand. And you also called the categories as instances of these things there. And data is also instances of the instances in this case. So what is the representation?
Not instances of instances. Everything is an instance. The blue layer is an instance, and black layer is an instance of the ontology. I'm just not showing all parts of the ontology here.
Okay, understood. So actually, the categories and data are both basically instances of the concepts defined in the ontology, you said. All right. Okay, and you said OWL somewhere on the concept layer, or no?
We're not using OWL currently because OWL is a bit restricted in terms of what we can do. So what we just created our own model, and then the reasoner is, could operate on a Sparkle query, on what construct query, or so on. So we kind of, maybe there could, we would have to bend OWL so much. I think this is still more, but I can explain a little bit more about the instances. So what's missing here, like this, for this picture, it's a little bit diluted, but it's only the part for the home furnishing, or for these interior designer rules. So it's only this, like that it's based on product attributes, and there's a rule for accessories and a rule for furniture. And then the direct instances are there. But the actual products which are on the data level, they are all instances of the product class, and the product class is in a different ontology module. And we have two modules currently. We have our product module, which is kind of describing all the attributes of the product, and product attribute here on this green layer, the product attribute that actually comes from this product ontology and product module. And then we have the interior designer module, which is about business rules. And its instances happen to be very much on the specialized instance level.
Okay. Good. Just for my head to clarify, because I thought you were doing some meta modeling or something somewhere, so that was all right. Good. Any other questions? Okay, maybe first do this, and then you were like,
Come over.
Or you come together, and then yeah.
Come together right now. Please come over to this side of the table.
You also have to watch out time a little bit, so I hope so.
How do you rank your recommendation in this case? I'm wondering, if you run into any sort of a potentially a conflict when you generate the recommendation. Just curious.
Yep. So we did get some funky combinations, and then we realized that there was a problem in the rule. So our knowledge expert, who is an IKEA expert but really non-technical, has sometimes a little bit of problem of understanding all things of logic. And we're now pairing them up also with a person who has a computer science background so that they could really help them understand the logic a little bit better. But we saw that some of these business rules were not defined correctly when it comes to logic. So it's still an ongoing process and learning. But we are also writing guidelines or actually guides for them on how they can really create the logically sound business rules. And also it's an ongoing work. We're developing the business rule creation as well as the interface for it all the time.
One last question for you.
Oh, how we validate the recommendations? Rank. Oh, we rank them by and also interior designer rules. So we order them by the style appropriateness. Colors would come into this as well, and the price. So that's how we rank them. And then you can add personalization to it. So if a customer's been buying products in a certain color, then that can affect the rank as well. In e-commerce stores, there's usually 20 factors that contribute to ranking. Something is the availability in the country, the other is profit margin, then there is personalization, and then our interior designer. So first we do an interior designer ranking, and then we ship it off, and somebody else can put their margin ranking on it, and so on. Here, please.
So,
closer, please.
yes, just to understand the concepts that you have. You have 100 concepts, and then you have rules. So these concepts are normal ontologies with entities and relations and axioms that apply to these entities, or you consider the rules as direct elements of the ontology?
So the concept is basically your classes and properties. The rules are instances of classes. And the rules are our own language. It's like we say that when there exists the product attribute of cushion and the product attribute of suitable for indoor, then we can conclude that this is a cushion for indoor. And so we are not using OWL, we're not using axioms, we're not using the standard things, we're actually using our own instance and rule engine for it.
I understand. Then what I would say is that what you say, so first it confirms what we observed in OntoCommons in IOF, and there is no standard way to build ontologies. So, and we need to work on that. And you do it in your own way. You use the term ontology to define that. For me, it is a semantic model. That would mean you have not necessarily an ontology that you have. Then what you said, it is correct. To build a knowledge graph, the final end, it should be the knowledge graph with the data, and then you work on this data to do your recommendation, whatever. And vocabularies are essential to build ontologies, taxonomies, as you said, and then the highest levels in ontology in various levels with various modules that may help to link everything together. At least this is our conclusion so far. So,
Yeah. Well, I would argue that we have an ontology that is created according to RDF and RDFS completely. So maybe we need a session where I can really kind of show it to you, but it is an ontology. It's defined using OWL ontology. It has classes, it has properties. And then I believe that we are missing in this community an understanding of what high page rank instances are, because they play a huge role when it comes to enterprises, and it's completely overlooked.
And I also already have 1,000 more questions, and it's a great discussion, particularly from a technical point of view, and I will catch Katarina at some point at dinner.
Actually, I mean, we're all the time in the innovation prototype lab, so just come over, have my laptop there, and we can show you, I can show you all the things we have. So just come over there.
Okay, I guess this is more valid for people who are here, but still. Thank you very much, Katarina. And exactly, round of applause, please. Amazing. Great talk, very insightful. And now we have Bosch here. Yes. Are the online speakers able to hear us? Maybe now. Maybe now. Here, but yeah, okay. But here is, I think now, okay. So online speakers are also able to hear us, I'm hoping. All right, now the last talk for today, for this session, the demonstration session is from Bosch. Evgeny Kalamov and yeah, exactly, Georgian Cheng are here to give this talk about the industrial commons for analytics in manufacturing.
Hi everyone. So the talk today will be split between me and Shin, my PhD student, with whom we work on semantics for Industry 4.0. In this talk, we will go through a few things. We will present what we do in OntoCommons and also link it to DOM 4.0, this back-to-back project of OntoCommons where ontologies are used for smart dataset search. This is a joint work by several people, by me, by Shin and Elsa, by other colleagues from Bosch, from Uni Oslo, from other partners of OntoCommons. So basically, it is an example of a collaborative work within the two projects where we develop things in a joint fashion. So the outline is that I will present manufacturing use case and talk about the Bosch welding ontologies. That will be my part. And then Shin will deep dive into the other parts. I will also talk about the connection to DOM 4.0. So I will talk about manufacturing use case, ontologies we developed, and some of the benefits ontologies give to us, namely dataset search. And Shin will go through the last two topics, executable knowledge graphs and the Python library that we developed. On top of this, OntoCommons ontologies. About the Bosch manufacturing use case. In our scenario, in our use case, the main challenge that we're addressing is one of the discrete manufacturing operations where you connect pieces of metal together. So this is a very common operation in manufacturing. Essentially, any big metal thing that is produced comes with some form of connecting it from pieces, and then welding is one of the most commonly used ways of doing that. And there are multiple ways, multiple machines. There is a high degree of automation in this particular operation, and it does require smart solutions for making this operation better. Namely, our goal in this use case is to predict quality of this discrete manufacturing operation, the quality of the welding, how well are the pieces of metal connected. More precisely, so what we predict, I think this will work as a mouse. Yes, without this one. Oh, this one. Okay, this is the others. So in this manufacturing, so you connect pieces of metal together with these special dots. And then this is what, when we talk about quality prediction, we predict the quality of those dots based on the information about previous dots that have been done. In this use case, we rely on massive data. Since it's, as I mentioned, it's an automated, highly automated manufacturing operation, the robots that do this operation, and it looks like this on the picture when this bunch of robots connect metal and then they build these car bodies. There are lots of sensors deployed on the robots. There is a lot of other information that comes from the robot, the type of the program used, and so on. There are thousands of programs that the robot can use to do this welding. And if you look at one production line that makes, say, up to 1,500 these car bodies a day, then in one day you get enormous amount of data generated by the robots. We're talking about up to 14 billion data items generated a day. Clearly, this data is very valuable because this data contains information how this line worked, and by relying on this data, one can predict how the line will behave tomorrow and analyze the previous day. And so basically, our goal is to combine this data generated by robots, combine simulated data, combine some lab data, and use it all to predict quality of welding. And in the classical way this is done is through machine learning pipelines, where effectively how it works is that you take the data generated by machines and some other data, you negotiate the tasks among parties on what and how you would like to predict on this data. You prepare the data, you analyze the data, you interpret results, you deploy your machine learning model, and then you send this feedback of this model of the data back into the original data collection. So these are the three main steps, split in the sub-steps that we do in analytics. And actually, this comes with really important challenges. One is that when people have to communicate, they can be pretty lost in the terms when they decide what to do and how to do. The second thing is the data integration itself is a big challenge. As we know, these 2 steps per second alone can take about 80% of the whole analytic tasks. And then even if we develop some manufacturing this AI solution, then reusing from one production line to another is hampered by the fact that the solution can be too much tailored for one line, and it's not really easy to reuse it. These are the challenges that people face when they do this type of analytics, and we are addressing these challenges with semantics. In OntoCommons, in the DOME project, we tackle these challenges by throwing in semantics into the game. How exactly we do so? We develop specialized welding ontology that is based on various standards, and I would say a bit more about that. And as soon as we have these ontologies, these semantic artifacts, then the whole process that I've described can be really improved. And how exactly it can be improved, it will be the second part of the talk that partially myself and Shin will present. A few words about the welding ontologies. When we started working on that, of course, we looked at what exists out there. Maybe we can just take a good, beautiful ontology developed by someone, and it will be already standardized to the teeth, and we can just use it as it is. Apparently, it is not. We looked through whatever is there, so it's not that there is nothing. There was already something because it's very popular and very common manufacturing operation, welding. So basically, we were unsatisfied with what we discovered. And we developed our own ontology jointly with OntoCommons partners. And so this is the resistance spot welding ontology that you see in the lower line. This is our ontology that ticks all the necessary things that we need for the welding operations, welding resources, and other functionalities. Then, in order to develop this ontology that satisfies our needs. So what we've done, so our development process was that we went through a few stages. We started with the requirement specification. We've been formalizing the concepts. Then we validated ontologies that we developed through the formalization. And then we also made our ontology at the moment, at least partially available, but we would like also to release it as an artifact that can be used and benchmarked by others. In this process, So we put together ISO standards. We put SSM, the source ontology. We took our OS ontology developed in Galway, and we rely on Dublin core. So we took a blend of some of the international standards, standardized ontologies, our internal expertise, and we put it all together to create our ontology throughout the steps. When we did this, so we also made our ontology composed of several blocks. It's not like one unified thing. It consists of several components. And by developing these individual components, we also made alignment across the components. So there is just a sample of examples, few snapshots on how this ontology look like. So the statistics of one ontology, that it contains about 900 axioms. So then some of them logical, some of them not. So it has more than 100 classes and about 100 object properties with about 70 data properties. It's not a huge ontology, and it was never the aim to construct a beast with thousands and thousands of things. The main thing was to make sure that we do cover the main vocabulary of welding and the standardization initiative that has been done in this in ISO and so on. Right. So when we done the ontology, we did evaluation jointly with OntoCommons colleagues. We did evaluation against some of the OntoCommons guidelines. We haven't finished yet, so we are still continuing evaluating it throughout this year. And we are preparing results of evaluation also for a workshop that we will be running at the International Semantic Web Conference later this year, where we will take a number of ontologies evaluated through the DOM project and OntoCommons with OntoCommons evaluation and standardization methodology, bring it together to the international community later this year in November. Currently, our evaluation results were based on ontology interviews, were based on the fairness evaluation and some other things. The result that we managed to get so far on ontology development and ontology evaluation we already published in an international journal, and it was just recently accepted. And we are very happy that we can already share our results with the community. Now, ontology is there when it's few things still and will be done on top of that, but we do already have a stable artifact. Now, how this artifact can help us? So one thing is it can help us in finding the right data. So as you remember in this machine learning, in this data analysis pipeline, gathering the right data and bringing it together to do the predictions is really critical. So what we do, as I mentioned, there is a huge amount of data. And this data, when it is converted in the semantic artifacts, in knowledge graphs with the help of ontologies, then what one would need to do, one need to find the right data at the right time. And this is what we focus on within the DOM project. So there, our use case is to find through the DOM platform relevant data pieces of data that are necessary for concrete analytical tasks. And by doing that, we take our ontology developed in OntoCommons, we align it also with the ontology of dataset search developed within the DOM project. So this is one thing. We can now do the data search through data marketplaces by just plugging our ontology, just by aligning our ontology to ontology of the DOM marketplace. This is one benefit that we get immediately from that. Then two other benefits that ontologies and then simplification brings in will be communicated now by Shane. He will continue. Okay.
Hello. Yes. So the second benefit is the executable knowledge graph. We call it XKG. Okay. Yes. So executable knowledge graph is benefits the machine learning practice in industry. And here the machine learning practice in industry refers to basically three analytics, namely visual, statistical, and machine learning analytics. Because in industries, these three parts connect with each other always. Yes. And yes. So currently, the machine learning practice in industries mainly face three challenges. The first challenge is transparency, which means for those non-machine learning experts, they always find it hard to understand the machine learning algorithms or pipelines. And the second challenge is that because in industries we have higher requirements that the pipeline should be documented. However, these machine learning solutions are hardly described or documented in a formal way. And the third challenge is the reusability, because these data pipelines for machine learning solutions are always developed in an ad hoc fashion. And so especially for those non-experts, they always find it's hard to reuse in a similar scenario. Okay. Okay, yes. To address these three challenges, so we propose a executable knowledge graph system which combines semantic technologies and data analysis. And in particular, so because it uses semantic artifacts, which combines domain and machine learning knowledge, which facilitates the transparency to the non-experts. And then because in these systems, the data pipelines are presented in knowledge graphs, which is formal, and then so it provides a standardized documentations for the machine learning practices. And at last, because these knowledge graphs can be executed in some modularized scripts, so in this sense, this machine learning practice, the reusability and usability will be increased through this system. Yes, this is artifact. So architecture of these systems, basically it consists of three layouts. The first layout is semantic artifacts, which so use ontology, which combines the visualization, statistical, and machine learning ontologies. And in the second layout, so the users can generate knowledge graphs based on these ontologies in the first layout. And then in the third layout, these knowledge graphs can be executed. They can be translated into some executable scripts. And so through that, the machine learning practice can be improved in industry. So yes, this slide shows the basic structure of the ontologies, the data science ontologies. So like we see we define the pipelines as an ontologies, and it consists of a series of tasks, and each task will invoke some methods and will have some data as input and has data as output. So it is quite intuitive, and so this is the ontologies partly. So the data science ontology is so at the left top. So it is the higher level ontologies, and visualization, statistical, and machine learning ontologies are generated based on these data science ontologies. So this is the first layout in the systems. And in the second layout, so the systems can generate, can help users to generate knowledge graphs based on the ontologies. So here, so for easy pipelines, these knowledge graphs can be generated from scratch. So for example, so like to generate the picture in these slides, so the users need to first build a canvas, and then so plot different data in the canvas, and then add some descriptions like the legend. And these pipelines can be generated, can be represented through an ontology like that, and it is somehow simple, and the users can generate it from scratch. But for complex pipelines, so mainly it's machine learning pipelines. It is almost impossible to ask users to generate the knowledge graphs from scratch. So for these complex pipelines, so we can the users can can reuse some knowledge graph and to build a complex one. And in the third layout, so these knowledge graphs can be translated into scripts, and so to finish the tasks automatically, right? So that is the second benefit, and third benefit is follows the second one, and so that is so a Python library which is built for executable knowledge graph systems. Yes, so yes, it also benefits the machine learning practice in industries because it is a useful tool for users to use to write machine learning scripts. Yes. Okay, thank you.
Okay, so I will then wrap it up. So in our manufacturing use case, what we need an end-to-end solution. End-to-end solution that starts from the idea that people have for manufacturing optimization, like let's improve the quality of manufacturing, until the very end of developing and deploying and executing the concrete manufacturing solutions. And we try to address it in a holistic fashion. We develop ontologies that on the one hand describe data, but it also describe a bunch of other domain knowledge, which is relevant to close the whole loop from the beginning to the end, this end-to-end thing, from domain description to task descriptions to machine learning practice descriptions to dataset search necessary descriptions. We also, in another EU project, look at the cloud description, how to describe the cloud infrastructure in order to deploy our pipelines automatically to the cloud solution. So what we're working on is the zoo of ontologies that covers this whole thing that we need end-to-end, and that allows to do this, to democratize actually the machine learning, to democratize AI for manufacturing, democratize it through this lowering this barrier of this of AI for manufacturing, where people who are not familiar, who are not experts in machine learning, can come into the game and can do the whole thing. Link the data, find the right data, create machine learning solutions, deploy machine learning solutions, get the results, and bring it back to where they started with. So this whole thing, which is now possible to do only if you have really advanced education in data science, we would like to achieve. We would like to offer this thing for people who don't have such a background and who can do it with the help of ontologies. And we do need to do it in a standardized fashion to make sure that it's scalable, yes, so that where OntoCommons help us. Thanks.
Thank you very much. Before we go to the questions, Stan and Eric had an announcement, right? If you're here. And meanwhile, we can think of questions in your head. And I know we're a little bit over time for lunch, but technical issues, we were a bit late. So.
Announcement about the dinner?
Not really. We have created yet another survey. I'm sorry to say that. My deep apologies and my condolences. The reason behind this survey is that we want to be able to respond to a follow-up question from the Commission. That is, what kind of activities or what kind of projects or what kind of functionalities would you like to continue to develop after this project is done? So this survey here will hopefully get some indications of what we are doing now, what kind of tool sets we are using now, and what kind of improvements we want to see in the future when it comes to different processes. The survey is segmented into areas such as learning and skills environments, for instance, when you are learning and getting into the area, and implementation, challenge management, work when you are evaluating existing ontologies, when you are developing ontologies, when you are deploying them, and when you are maintaining them and further development and such. So hopefully by answering these questions, we will be able to see what kind of improvements we can offer or work towards in a future proposal or future group of proposals. So please fill in this one. That is the demonstrators. So we will be eternally grateful if you could do this. So I'll leave it here. So is it okay? Okay. You can get it here and hopefully maybe you can deliver it back to you again. Yes, very visible. Yes. Thank you very much. And yeah, take this seriously, because I think this could be a good foundation for planning for next group of proposals. Thank you.
All right. Any questions for Bosch? Maybe too many diagrams in this slide. So it's, too close to lunch. All right. Anybody from the audience? I also don't see. Yeah. I mean, oh, sorry, I didn't see. Yeah. Maybe I repeat the question. If the question was if the ontology is available on the OntoCommons ecosystem or OntoCommons portal.
Not in full, at least. Not in full, at least. So yeah, but this is something that we are planning to put it. So the welding ontology plus the surrounding ontologies to deploy it to put them into the OntoCommons portal until the end of the project.
Then one final thing for us, for our future work, basically after the workshop, is there anything, so you tried, the same question as Katerina, basically, in terms of like adapting some technologies, is there anything you tried but didn't create the impact that you were expecting? So,
yeah. So something that that hampers the impact. The main thing that hampers the impact is scaling the ontology usage, in the sense that if we automation of the ontology construction process. So that's something that we see that we can create ontologies. We go through welding. We invest a lot of energy with people who have PhD in ontologies. They spend some time, and then at the end you have really beautiful singing and dancing ontologies that can, say, address welding. If you go from welding to drilling, bending, and you name a bunch of other operations, you have to restart this thing again. And then the question is, who will be going through all of that? And if we're talking about hundreds of discrete manufacturing operations, then one needs the whole army of ontologists to do this thing. And the big question for us is how we can, do this ontology development and scale with people who are domain experts but not PhD in ontologies. So that's a big thing. So some magic box which you press the button and it starts helping you. ChatGPT for ontology construction, you talk to it and it comes back to you and tell you, here is your beautiful ontology, it all standardized, it all follows whatever you want. Just take it and use it. So that would be yeah. Sorry, there is a comment. Yeah.
Have you been? Oh,
yeah, the microphone wants to go to lunch.
Yes. Have you been talking to colleagues from Siemens Energy? Because Siemens Energy is doing exactly that. They're using a ISO standard. The only thing I remember about the numbers, it ends with 14. But it's something 1, 2, 3, 0, 5, 14, if I remember correctly, but probably not. And what they do is they have the engineers who are experts of all these technologies you just mentioned, these manufacturing technologies, and they have a standard way of how they can, like, with click and drag and drop, create the ontologies. And it's using this standard, so actually they get really good quality ontologies. Andreas Neumann from, you should connect with him about it. It's really interesting. I mean, you saw the presentation as well in Heidelberg. So this could be a way. I want to look into it as well, because I'm getting also some problems with as the ontology creation now spreads throughout IKEA.
This is actually an excellent comment. So Andreas, so I saw the thing that he's been developing, and we've been in touch with him, and also the initiative that Adult Vale has, where he and colleagues they also create this IMF framework that also meant to mediate between the ontologies and the mortals who can just communicate to this IMF, and through this communication, ontologies can eventually come at the high quality. So that's indeed, there is a number of initiatives, and definitely that's something that maybe deserves the whole EU project by itself, is how to make this accessible and scalable. And indeed, so Andreas tool is a great one. Yeah.
All right. Thank you very much. Maybe outside. Yeah. Yes, because we are already a little bit behind on the lunch schedule, and also not fair for the next session, of course. If you have further questions, please take it during the lunch with Evgeny and also in the poster session. Yes, when are we back? At 2 o'clock, we are back here again for the next session. And enjoy lunch. Thank you very much for joining.